Mrs. Banky here, today to talk to you about electronic balances that are used in the lab setting in our science classrooms. And we have a variety of different models here that have different applications. So the first one I want to talk to you about is, it's a small, relatively inexpensive electronic balance that can be used for most scientific applications. So there is a cover here. To remove it from the cover, you have to just turn it upside down like this, and then take this cover off like this. There's a small button on the side right here that says push, and this screen pops out. Now if you try to turn it on, it will not turn on unless you have it flat on the table. So if we turn it on, here's an on button, a mode button, and a tare button. So I'll turn it on, and you can maybe see that it's measuring in grams. Most of the time our measurements will be in grams. If we do need them in a different unit, there are ounces and DWT, which I'm not sure what that is, or OZT, which I'm not sure what that is either. Obviously not that useful to us. If you want to have mass out a powder, you can actually use what's called a weigh boat, or you could use a beaker, and either one can be placed on there. Now, whichever one I choose, I'll use this one for right now, whichever one I choose, I want this to become part of the electronic balance itself. So if I hit the tare button, now it's back at 0, and now this is part of the measuring device. So anything that I want to get the mass of, I have some alum here. I'm not wearing goggles because it's a relatively safe compound, and I'm using a scopula to place it in there. And let's say I wanted 3.0 grams. I'm not sure if you can see the numbers there, but I have a lot of control with the scopula. There it is, 3.0 grams. So if I take this off, you'll see that it's measuring now in the negatives. That's because I did make this balance become part of, or the beaker become part of the system. So this has a maximum capacity of 1,000 grams, I think. I'm going to 0 it again, hit the tare button, and then I'm going to shut it off. And to close it back up, you just have to pinch that shut. This smaller, shorter cover sits on the top like this, and the back goes on like that. Now, one thing that's really important about these electronic balances is that if they get wet for any reason, you need to let your instructor know, because most of the time it won't cause too much damage if we can get it dry. But if we don't know about it, the wetness can get into the batteries and cause corrosion at the points where the batteries contact the metal there. So if for any reason the balance becomes wet, you need to let your instructor know. So closing it up again, putting the cover on the top, the short cover, and then that's sitting in there like that. So the 3 balances that I have here are all, they all measure out to the 100th place. This balance measures out to the 10th place. Now, in some experiments, we need a higher degree of accuracy. So these machines are far more expensive, and they measure out to the 100th place. So I'm just going to turn each of them on. And it takes a little time for them to think. This is an oldie but goodie, and it actually is pretty reliable. I typically don't have it out, but I'll take it out if I'm in a pinch and I need to use it. I thought it would be cool to include. So as I turn it on, they all read 0.00. You can see they measure out to the 100th place. And machines like this can be calibrated. And this is a a mass that is exactly 200 grams, and if I put it on there, I can get a sense of where this machine is. This machine is calibrated. It is virtually 200.00 grams. If I compare this machine, this says 200.27, so significantly over the 200. This machine should be calibrated. Let's see what this one says. Our oldie but goodie, 200.23 grams. I have no idea how I would even begin to calibrate that old dinosaur, but like I said, I will use it in a pinch. Now, even if the machines are not calibrated, they can still be used pretty reliably, because oftentimes we are looking for the mass of a substance before a reaction and then the mass of the products after the reaction. So we're looking for differences in, you can put it on, so we're looking for differences in the mass before and after whatever the event is that's happening in the lab. For that reason, because they may have different calibrations, if you are using this balance in a specific lab activity, you need to make sure that you continue to take measurements on this balance. That will give you a better level of reliability when you're measuring things. This said 0.27, that was 0.27, different than that. So it's very important over the course of an experiment that if you start with this electronic balance, you finish with this electronic balance. If you start with this, you should finish with this. So this is a weigh boat, and if you bring that back in here, the weigh boat can also become part of the electronic balance. I hit the 0 button, and we don't ever want to directly put powders onto the electronic balance. So it's highly sensitive, and I would record the mass of this to be 0.51. And then if I had to make a mass afterwards, I would just do it again on the same scale. Now, these scales are very sensitive. You can see that wind currents are causing this to fluctuate. So it's important that there's not a lot of activity in the lab, because it can really cause this to fluctuate. These machines are highly expensive. They cost several $100s. For that reason, it is very, very important that you never push down with your fingers on these machines. This is the maximum capacity. It's not a lot. This 200 grams is the maximum capacity that these balances can handle. Any force beyond that is going to cause the balance to become not calibrated and sometimes permanently damaged. I've had a balance permanently damaged one time. I came into my classroom and there were things stacked up on the balance and balancing in this it was actually a pretty impressive arrangement, but all of that weight on that balance broke it. Several $100s, I have no idea who did that. So for that reason, it's important to follow lab safety rules set forth by your instructor. If you have to transport the balance from one place to another, you can shut it off. This one you have to actually hold it off and it gets shut off. You can unplug it. And it's very important just to get a good grip on it with two hands and carry it from point A to point B. Set it down gently and you can plug it back in and turn it on again. Be very, very careful with these balances. We don't have a lot of money in the department, and with them costing several $100s a piece, it's extremely important that you treat them with care, you treat them with caution. Anytime liquids are being measured, you be very, very careful not to spill. You use all of the equipment that you can use to make sure that you're not splashing liquids on there or other chemicals. You always measure powders and such in an appropriate vessel like a weigh dish or a small beaker. So if you have any questions about the electronic balances, just see one of your science instructors here in our department, and we would be happy to help you. So that is all I have for today. Thank you for watching. I hope I didn't forget anything. If I did, maybe I'll add it. But I think this is it. Thanks.